Hello everyone. In this video, we'll be looking over transformations of quadratic functions. When we look at transformations, we're talking about how we transform or move our base graphs to other graphs with different values in the equation. Every time we look at quadratics, we should be looking at vertex form, which is the following here. Y equals a, x minus h squared plus k. This is our vertex form equation. Each of these constants, a, h, and k, control how we transform our graph or how we move our graph on our grid. We're going to look at those separately and then bring it all together at the end. The way we do that is we start with what we call our base graph. So here, y equals x squared, this is our base graph. It's very important because you always start transformations by graphing the base graph. Okay? In order to graph this, what we need is to use the table of values below it. I have provided x values. What we need to do is substitute those x values into our equation in order to solve for y. So let's do that. Well, I'm going to plug in -2 for x, and if you square that, you get 4. I'm going to continue to do that for all these values of x in the table of values. And if you continue to do that, you should recognize somewhat of a pattern in the table. So now that we have all of these values, we have a list of points we can graph. Let's go ahead and scroll to our grid here and graph those points. So the first one we have was -2, 4. -2, 4 is right there. Then we have -1, 1. We have 0, 0, which is our origin. We have 1, 1. And we have 2, 4. What you want to do is connect those with a smooth curve to the best of your ability and extend it beyond the points. Now also, if you're not using colors, it's best to label your graphs with the equation that corresponds to it so you can tell the differences between them. Next, we still have a quadratic function, but now we have this +2, okay? And if you look at the base equation that I wrote at the top, that +2 is our k value. So when we graph this, we're going to be looking at what happens to our graph when we change the k value. Okay, well the k value is +2 here. So again, in order to figure out our values of y, simply plug in or substitute that x value I've given you into your equation and solve. Well, -2 squared +2, that's 4 + 2, that's 6. Go through the table of values and see if you can complete those now. Pause the video and then play it when you think you're ready to check your answer. These are the values you should have got. Again, you see somewhat of a repeating pattern. Now, again, scroll down, move it down so you can see the grid, and plot those points. So the first one is -2, 6, which is there. -1, 3, 0, and sorry, that should be not 0, that should be 2, 0 and 2, 1 and 3, and 2 and 6. And again, connect those with a smooth curve. And I would also again label that graph of the equation. Now what do you notice about what happened from our base graph, which is in orange, to the transformed graph, which is in red? It has moved up. We call that a translation. When you move the graph up or down, it is considered a translation. And that's what we're going to get into describing right here. So for y equals x squared plus k, describe what the k value seems to do to the graph. Well, right here, when this is this would be when k is greater than 0, if you remember what those symbols mean. And in our example, it was 2, which is greater than 0. It becomes a translation up by what we call k units. So if k was 3, we would move it up 3 units. If k was 4, we'd move it up 4 units. But here it was 2, so we moved it up 2 units. When k is less than, so if we had the opposite of the example, say that said -2, it would be a translation, translation down by whatever our k value is, pending that k value is negative. Okay, and we have one more graph here to observe, and in this example here we're looking at a h value. If you look at the vertex form equation at the top, this +2 is now an h. So we're going to see what happens to our graph when we add an h value that is not 0. So again, we're going to solve for our table of values, plug those things in. Y is equal to -2 plus 2 squared, which is 0. Again, pause the video here, complete the table of values, and play it when you're ready to check your answers. This is what you should have got. You'll notice that they're not really in a repeating pattern like the first two, but that's okay. When we graph this one, we're only going to be able to see about half the graph just because I chose specific values of x. That's fine too. So -2 and 0 is right there. -1 and 1 right there. 0 and 4. 1 and 9. And what you notice is 2 and 16, based on the scale I've created here, it doesn't work. Our y-axis only goes up to 12, so we don't have to worry about graphing that final point. And again, connect them. Okay, we only have half of our quadratic function. If we were to graph the other half, what we would notice is values like this. I'm going to label that, and then I'm going to observe what happened from the graph in orange to the graph in green. Well, if you look at it, it basically moved left. So in conclusion, our h value controls transformations of moving our graph left and right. Okay, this one is a little bit trickier though. Sorry, this should say h value, not p. For y equals x minus h squared, describe what happens. Well, when h is greater than 0, here our h value was +2. One thing you have to remember when you're looking at h and you're deciding on the transformation is that you have to, it's always opposite sign of how it appears in the brackets. So in this example, it was x plus 2. So we want to consider that our h value is actually -2. Okay? It's a little confusing, but just remember our h value, we always interpret it as opposite as we see. So, and that's why I put these little hints in brackets when you see x minus a number or when you see x plus a number. So in this example, we saw x plus a number, and as I said, h would be less than 0, because if it was +2, the opposite is -2. And what happened there? Well, that would be a translation left by however many units or value h was. And the opposite then, you can imagine if h is greater than 0, if you see x minus a number, it would be a translation right by h units. Okay, so we have summarized the h and the k transformations. Important to keep these notes handy when doing your work. take a pause, review that, or when you're ready, move on. So let's try and start these transformations from the beginning and apply them again just to get a little bit more practice. So again, we always start with our base graph. Okay. Well, our base graph is y equals x squared. You're going to want to make a table of values for that. And it's fine if you use the same values that we used in the first example every time you do this. Okay, if you remember what those values were for y as well, that's what they were. Okay, you're always going to want to start by graphing that. Now in our first example here, we have y equals x squared plus 3. That plus 3 is a k value. Okay, so to apply k to our transformations, we don't need to make a brand new table of values. What we want to do is, because it affects our graph on the y-axis, meaning it moves it up and down, to apply k, add your k value to each of the y values in your first table. So what does that look like? Well, I'm going to keep all of my x values the same because they're not going to change, but my first y value was 4. I'm going to add 3 to it. Now it's 7. 1 plus 3, that's 4. 0 plus 3 is 3. 1 plus 3 is 4. And 4 plus 3 is 7. So this right here would be the graph for y equals x squared plus 3. Okay, and we'll graph that in a second. I just want to get kind of all this work out of the way first. And for the last one, we see there's another equation up here, y equals x plus 5 squared. That plus 5 is our h value. And I'll make a little note again. To apply h, we need to add your h value to each of the x values in your table. Okay, because this is a translation left and right, we are moving along our x-axis. That's why we're going to have a change in x, and we're going to add that value to our x values. So in this case, we can keep all those y values from our original table the same. And we're just going to be changing our x values. Now remember that h is always opposite as it appears in the brackets. Here it is plus 5. However, our actual h value isn't positive 5. Our h value is negative 5. It's opposite. Okay, well, if that's the case, what's negative 2 from our first table plus negative 5? That's negative 7. Negative 1 plus negative 5 is negative 6. 0 plus negative 5 is negative 5. 1 plus negative 5 is negative 4. And 2 plus negative 5 is negative 3. And now we have all of our table of values, and we can graph everything we see here. So let's graph all of these again on the same grid. Our first one, we're just going to use a scale of 1. So each grid box is 1. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. There's your base graph again. Should be starting to get the hang of graphing that. And again, make sure every time you label this if you want full marks. Okay. The next one we're looking at is y equals x squared plus 3. Negative 2, 7 is the first point. That's right there. Negative 1, 4. 0 and 3. 1 and 4. And 2 and 7. Okay, there's that. And again, you're going to want to label that if you're not using specific colors. And the last one we're looking at here is our h value, and that was our equation y equals x plus 5. We graph the last one, y equals x plus 5 squared. So notice that it translates left, and you have graphed all three on the grid properly. You've labeled, and that would be full marks. Review that part, or if you're ready, move on to the next section. For these questions, we're asked to list the new equation if these transformations occurred onto our graph. So, for each of the following transformations performed on y equals x squared, our base graph, write the equation of the resulting graph. So the first one says shifted left 3 units, or another word for that would be translated left 3 units. So if we're moving left or right, we know that this is our h value. Okay, so we're just going to have to include an h value into our equation. Our h value, if you recall, and I'll just draw the basic vertex form function, is in the brackets. Okay, if it's left 3 units, it means we added negative 3, and it would be opposite. So our equation becomes x plus 3 squared. Because if we were going left, right, we would take the opposite of plus 3, which is negative 3, and we would add 3, and that would shift everything to the left. Okay, the next one we're looking at, it says translated up 7 units. When we're looking at a translation up or down, this would be a k value. If we're going up, it's plus 7, so what you would do is y equals x squared, that's your base, and we're translated up, well, our k value is simply added or subtracted at the end, plus 7. Okay, and then one that includes both an h value transformation and a k value, translated up 3 units and right 6 units. Okay, well, the first thing that comes first is h, so that goes in our brackets. And it's right 6 units, so it's going to be the opposite of that inside, which would be negative 6, and then it's up 3 units. Okay, so this 6 is h, and this would be k, and those would be our corresponding equations for these questions here. Review that, and if you're ready, move on to the next section. So, the final transformation we need to look at, and I'll rewrite it again, is A. We have not seen what A can do to our graph, and that is that coefficient right here out front. And we haven't seen what it can do to kind of change our graph. Well, again, we start with our base graph, y equals x squared. We should get in the habit of knowing this table of values very well. Okay, that's going to be our base graph. Okay, we're going to graph that at one point. What I want you to do now is go through B, C, and D and plug in those x values into your equation in order to fill out the table of values. And once you have that, play the video again to check your answers. These are the answers you should have got. Just a few things to point out here. For C, you will get decimal values. Decimal values are fine, or you can leave it as a fraction if you're more comfortable than that. So for example, for an x value of negative 1, the y value is 0.5 or 1/2. Okay? Now, let's graph all of these on our grid to see if we can see some sort of transformation. Okay, so the first one is simply our base graph that we've been graphing for a few examples now. And there's the base graph. Again, I'm using a scale of 1. If you want to use a different scale, that's fine. Okay, I graph the base graph. Take a second and graph the remaining 3 tables. So pause the video and play it when you think you have the answers. So hopefully yours looks somewhat like this, unless you used a different scale. Again, make sure you've labeled each of your graphs, or you use some sort of color, or you've done both like I have. Okay, the original is the one in orange, and then we have 3 different transformations that we're going to make conclusions about based on the A value. So, in blue, we notice that compared to orange, it's gotten longer and narrower than what we had. Okay, so when A, this means this portion right here, when the absolute value of A is greater than 1. Now I write that because that's what these 2 lines outside of A mean. It's the absolute value of A. The absolute value of anything simply just means the positive version, or the positive value. So if it was -2, you would say the absolute value is 2. So when it's greater than 1, and for our graph in blue it was 2, so it is greater than 1, we call that a vertical stretch by A. So whatever we've done, we've stretched it by a factor of A. For the next one, when the absolute value, this says, is greater than 0 but less than 1. So basically when you're looking at a fraction, so if you notice you have a fraction, it's not a stretch, we call this a vertical compression by A. And that would have been our y equals 1/2 x squared, and for the first one that would have been our y equals 2x squared. So a stretch, you can envision that you've grabbed the top and the bottom of the parabola and you just pull it apart, which stretches it out, whereas the compression, which is the function in green, you've taken the top and the bottom of the parabola and you've pushed it together like you're making a sandwich and you've squished it, and that would be a compression. Okay, and then our last one, when A is less than 0, so when it's a negative value, and that wasn't our last, and it had, although you didn't see it in the equation, it's up here, because there's a negative out front, you know it's -1. When it's less than 0, what you've noticed, it's been flipped. It's been flipped over the x-axis. You can imagine one of those symmetry mirrors you used in elementary school. It's been flipped to match it perfectly. We call this a reflection, and it's in the x-axis. So if it is negative, you're going to notice that your parabola is going to be flipped over the x-axis. Okay? Now that you have A, you have all 3 of the transformations that you're going to have to worry about. You have the stretch, compression, and reflection, all corresponding to A, and then you have the translation left-right, which is the H value, and the translation up-down, which is the K value. Take some time to review that, or when you're ready, move on to the next part. So let's take a second to summarize. To graph a quadratic relation in the form y equals a x minus h squared plus k, remembering that is our vertex form, you're always going to graph the base. We've started with that every time. Apply the a value, and there is a reason I've listed this somewhere. You must do it, and I'll even make that must do this in this given order. Okay, you must always apply the A value first, which is your stretch, compression, and reflection. and you're going to do that by multiplying the y values in your table by a. And then you're going to apply the h and the k values at the same time by adding h to your x values and adding k to your y values, and we've already done that. But let's do this all in one example so we can have something to reference. So here's our equation. The first thing I recommend that you do is list all of your values. So what is a? Well, a is 2. That's that first coefficient out front. Our h value is what here? It's whatever's in the brackets. Remember, it's opposite. So here it's plus 5. Therefore, our h value must be negative 5. And then our k value is what comes at the end, and that is negative 3. Okay. Now, step 1. Let's start with our base graph. Okay. Well, our base graph is this table right here. And I'm going to just write it down as y equals x squared. Remembering the values that we used before, we can just use those again. Okay, and the corresponding y values to those are as follows. Now, the first thing we want to do is we want to apply our a value. So from here to here, we're going to apply a. And how are we going to do that? By multiplying a by our y values. So we have x, we have y. Our x values are going to be left alone because we're not doing anything to them, so I'm going to rewrite them. And we're going to multiply a by our y values. So our a is 2. So I'm going to look at this first value here, 4 times 2, that gives me 8. 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, 4 times 2 is 8. And we've done the first step. In the next table, we're going to want to apply h and k. Okay? And do it in the same step. So apply h by adding it to your x values, and also apply k by adding it to your y values. So let's go ahead and do that. We can do them one by one. So apply h by adding it to your x value. So h is negative 5. My first value of x is negative 2. Negative 2 plus negative 5 is negative 7. Negative 1 plus negative 5, negative 6. 0 plus negative 5, negative 5. 1 plus negative 5. And 2 plus negative 5 is equal to negative 3. So we've applied h. Now we need to apply k by adding it to our y values. K is negative 3. 8 plus negative 3 is 5. 2 plus negative 3 is negative 1. 0 plus negative 3 is negative 3. And these will repeat ourselves based on the same values we just looked at. Okay. Now you have all the information necessary. The only thing you want to do here is list, before you graph, is list the transformations. So if a was 2, what does that mean? What type of transformation? Okay, if h was negative 5, what does that mean? What type of transformation? And if k is negative 3, what type of transformation is that? Pause the video here and think about, if you can list them, what the transformation would be for each of those values. Play the video when you're ready to check your answer. So hopefully you have something like this. So a was 2, and remember, if a is greater than 1, it is a vertical stretch by 2. If h is less than 0, so it's negative 5, it's a horizontal translation, so it's moving left and right, left by 5. And if k is less than 0, which it's -3, it's a vertical translation down. The last thing to do is graph all 3 of our table values onto our grid. So again, I'm going to start us with the first one, -2, 4. We've been getting used to this base graph. -1, 1, 0, 0, 1, 1, and 2, 4. Okay, and go ahead and label that. Go ahead and see if you can graph the table in red and the table in purple and add that to your grid right now. Pause the video, check your answer in a few. So hopefully your final product looks something like this. You have all 3 of your tables included. They're all labeled or they're used different colors. And this question here would be repeated somewhere in the future, so make sure you're following the exact same steps. Okay, other than that, nothing left in this part of the video. There's a few practice questions here at the bottom that you can do to practice your skills. All the best, and ask any questions if you have them.